Um, Now, before we start our lesson today, I just want to check whether you have any questions or comments about qualitative data analysis last time. Okay, so for qualitative data analysis, the procedure is simple. There are steps and guidelines that you go through, but in order to do them efficiently, you need to practice. I have already told you that many times. With qualitative research, you need to have a lot of experience and practice in order to become, a good researcher. With quantitative research, it's hard in the beginning. I mean, you need to learn to work with numbers, with statistics. You need to observe the rules very closely. But everything is there. All the steps are there for you. You only need to go through 8 by 8. And that's why a lot of students choose to do quantitative research for their graduation exam or for their master thesis. Basically, it's easier to do quantitative research. I mean, to have a good research. It's harder to have a good qualitative research if you are not experienced. All right. Now, just a quick review before we start doing with statistics. Before we discussed qualitative research, we had a chance to work with central tendencies, right, and dispersions of data. Can you tell me again the 3 kinds of statistics that we can use to measure central tendencies of data that we collect? Central tendency. We want to see how data converge together. Mean, mode, and median. Easy. Okay. M. Okay. Triple M. Mean, mode, median. Right. So those are the descriptive statistics that we use to describe how data converge together. And if you read the samples articles that I showed you in the online journals, you see that very often you have table of frequency. Okay, table of frequency, and in the table of frequency, surely you see mean. Okay, and possibly mode median. Right, and by now, you should be clear about how to calculate mean, mode, median. You might forget the formula, but we practice and brushing up. Okay, I'm pretty sure that you can do it. So 20% of your final score will be for this part, right? So mean is the average value of the data set, and median is the value in the middle of the data set when you sort them from smallest to biggest. Okay, with the odd number of members like 7, 9, 11. It's easy. You only need to pick the one in the middle. But when the data sets have the even numbers of members, like 10, 20, 16, for example, then it should be the average of the 2 in the middle, like this one. It has 10 members in the data set. Now, mode is the values that occurs most frequently. So in a data set, we have 1 million 1 million value and possibly many modes. We call data sets with 2 or more modal values, multimodal. And then we also talk about measures of variations, how data can spread out from a central point in a set. And by looking at the variation, we calculate range, which is the difference between maximum value and minimum value, the variance, and the standard deviation. Well, standard deviation is more useful in helping us to, interpret the meaning of the data. So basically, 68% of the data set is within 1 SD and 95 is within 2 SDs. Hopefully, you are now familiar with that. Interquartile range is used especially when you do more advanced statistics. We are going to study that after this, especially in ANOVA and ANCOVA. Right, so range is easy to calculate. And variance, standard deviations. If you look at the visual chart of variance, you can see that basically variance helps to see how varied the data are inside the data set. Right, and we practiced this part already. We had a chance to practice a little bit. I make sure you have time to do that again. 68% of data within 1 SD of mean, 95% of data from within 2 SDS of the mean. Now, we are going to start with this today. Statistical techniques to explore relationships among variables. And the first kind of statistics that we're going to practice is called Pearson correlation. So to correlate means to have a relationship. For example, when I look at your test score, I want to see whether there is a relationship between listening and speaking skills. So I asked the office to give me the test scores of all the students. I look at listening score and speaking score, And in order to see, my hypothesis, my assumption is that students who listen to English well will also speak English well. That's my assumption, the hypothesis, but I need to prove that with the data. So I'm going to collect speaking score and listening score and do correlation test to see how they correlate to each other. Basically, what I expect is that students with low listening score will have low speaking score. Students with high listening score will have high listening score too. That's called correlation. So the purpose of correlational research is to discover relationships between 2 or more variables. Now the relationship means that an individual status on one variable tend to reflect the status on the other. So, for example, if I look at your test score, I want to see whether there is a relationship between listening and speaking skills. So, I ask the office to give me the test scores of all the students. I look at listening score and speaking score. So Now, let's look at these two examples. If there's a relationship between educational levels of farmers and crop yields, right? So this is a research question that we can do with correlational research. We have number of years of education, I mean number of years of going to school, and then the productivity of the farmer. Okay, the hypothesis is that the more educated the farmers are, the better. Okay, they can use the machineries, and the more knowledgeable they are about how to, take good care of the crops to have higher productivity. So this kind of question helps us to understand events, conditions, behaviors. We can also use correlational research to help us predict the future. Okay? And if you study business, these kinds of statistics is used a lot. Especially in the stock market. People can study statistics extensively, trying to predict when the stock market go up and when it go down, or at least they want to read the signals or the signs of the of the market, going up or going down in the prices. So if you learn to become a stock investor, surely you need to learn a lot about these things in order to predict the trend. We can only do correlational research when criterion and predictor variable, I mean the two variables that we work with, contain intervals data, continuous intervals or ratio data, like test score, years of experience, money. Okay. So this only works with interval and ratio data. Tell me again the four kinds of data that we have already discussed. Interval, ratio, what else? Nominal and ordinal. Okay, first, second, third, fourth. Okay. Now, these are some more situations, in which we can use Pearson relations, correlation to predict the relationship. So, in this test, I want to see whether the numbers of years of experience in work has anything to do with job satisfaction score. Okay? The assumption is that, and the employer wants to know too, the longer you stay in a company, the more satisfied you are with the job. But we are not sure. Okay? And in this case, the number of years of experience is the predictor value. I use the number of years, the length of stay in a company to predict the job satisfactions. In this kind of research, we want to see whether the family income of students have anything to do with the GPA, the average test score. We are not sure, but some people believe that students who have better family incomes, they do not need to care about part-time jobs. They can spend a lot of time on their academic work, and naturally usually they have more resources, computers, internet, and things, and they perform better. They get better at contest scores. But that's not necessarily true because sometimes when students face with hardships, they have very strong adversity quotient. And a lot of people are successful simply because they go through a lot of hardships. And likewise, a lot of people are not able to be successful simply because they enjoy too much comfort when they was in school. So we need to test this, and it's not necessarily true every time, but it may be proven with a specific data set, maybe inside a class, inside a school. But you see another interesting research. In this research, people want to know whether the distance of people from their home, to the donut shops, what we call these things, fast food restaurants, donuts that we others, whether it correlates with the weight. Assumption is the further you live from the fast food restaurants, the longer you have to travel, the longer you have to work, and the more chances you have to exercise. So these are possible situations that we can use peer region correlation to predict and to find out answer to our questions about events, behaviors, and things that we observe. Wow! I got a big wow at the beginning of the course when you saw this formula. But look at that again. It's not so difficult to calculate. Actually, this is even easier than standard deviations. Right, so you only need to calculate the sum of the two variables and put eight components in. Now when you do the final test, this formula will be given. So you do not need to memorize the formula. You only need to learn how to use this to calculate. Right. And this is the critical value tables. I will come back to this later and see how we use it. That's too soon. So I want you to practice with this data set. Now, so this is sample research. The student researcher wants to find out if her grading of student writing correlates with her supervisor grading or not. Now, this data, this is real data taken from graduate thesis in our department. These students do a research about using Facebook in improving students' writing. So she creates a Facebook group, add the students, and she's gonna post there and ask students to reply comments in English, just to give them more, opportunity to produce. And at the end of the practicum, about 3 months, she compare the scores of the two classes to see if they are different. Now, the problem here is that for the writing scores, it can be very subjective, and other people may question the validity of the writing test score of the students, right? So she needs to prove that her writing score, the writing score that she gives to the student, is fair and objective. She does that by comparing her scoring with her supervisor's scoring. Okay? The purpose is to prove that there is a strong correlation between her scoring and her supervisor's scoring. Right? Now, so the first thing I want you to do is use this formula and calculate the R value or the Pearson value. Now, so N, going to be the numbers of cases. Okay, so first thing first, this is X, this is Y. These are the two variables. It doesn't matter which one is X and which one is Y. In this formula, right? So let's say this is X, this is Y. So number one, we need to multiply X and Y, make another column, and then sum all of them up. So the sum will be here, sum X, sum Y, and we also need to have X squared, Y squared, sum X squared, sum Y squared, and put everything into this formula. Right? So how many columns do you need to add? Apart from these X and Y. So multiplication of X and Y, X squared, Y squared. So 3 more columns here, 3 more columns here, and 1 more rows here, for the sum. And then put everything into the formula, get the value. After you get the value, I will tell you how to interpret. Okay, so what is the R value? How big is it? What is R value? 0.9. Okay, once you get a different answer, 0.6 something. So what is your R value? 0.97. 0.95. Okay. Now, with Pearson correlation, the maximum value you can get for R is 1. You never get it. Okay, unless they are exactly the same. If they are exactly the same, you get 1. Okay, otherwise it's always 1 with that. Okay, let me try. So this is what we have to do. So cheat a little bit. That's, now, so first you need to create 2 columns for the 2 variables, right? X and R, and then, okay, I'm going to copy on the value for the first variable, and then copy on the values for the second variable. Okay. Now, next, you need to multiply x by y. So, x multiplied by y. And I'm going to put it here, right? By 3 and 3. Yeah, like that. Now, then you need to square x, right? X squared. Okay? So it's gonna be 3, 3. Make things easy for you. Now it is correct. Then you also need to square the y value, right? So it's going to be V3. Okay? Then we need to have, well, to make it easy for you. Okay, we have a sum here. Okay, so this is what you get. Right. So to begin with, you need to create a chart like that to calculate the raw data. Now, it's time for us to put everything together. Now, n here is 8. Okay. Number of cases. So it's going to be 8. Let me try to see the formula. Right. So it's going to be n multiplied by sum of x and y. So this would be D11. This one. Okay? What else? Minus sum of y multiplied by sum of x and y, yeah, B and C11. Right, okay? So that's for the denominator. Now for the denominator, divided by, well, it's going to be square root, okay? Square root of 8, that is n, and sum of x squared, so that will be e 11, right? Minus, well, we just go slowly, sum of x squared. Sum of x squared. So it's gonna be B11 and B11. Okay? So that's for the first part. Now this multiplied by n, right? Multiplied by sum of y square, sum of y square. So it's going to be f 11. Okay, this one minus by sum y, so that will be C11. Multiply with C11. Okay, and now close it. So it's 0.96, okay? Get 2 digits, so you see 0.96. Very strong correlation, but then we need to read the chart. So I need to come up with this answer. Okay. 0.96. Now, in order to decide whether there is a correlation, we need to compare the R value with the R value in this table. Okay, so the first step is to decide which row do we use to compare. Now this is a similar procedure for the latest statistics, so pay close attention. First, we decide the degree of freedom. Degree of freedom. Well, don't try to understand it now, okay? Just understand that df, or degree of freedom, is the row that you read the data. Now, degree of freedom is calculated by n minus 2. In this case, it's going to be a minus 2. That will be 6. Okay? So, this will be this row. So, we use this row. Okay, 6. Now, in the exam, you will be told to do one-tail or two-tail test. Okay, normally we use two-tail Pearsons. Two-tail means you need to compare all the two directions. But for now, we just stop there. We use two-tail, and with two-tails, the critical value that we always look at is 0.05. 0.05 means 5%. And basically it means at this value, there is a chance of 5% that our conclusion is wrong. Okay, let me say this again. 0.05 means when I use this value at the cut point to make comparisons, there is 5% of the chance that my conclusion is wrong. But I have 95% of my conclusion is right. If you use 0.01, there is only 1% that your conclusion is wrong. If you use 0.001, there is 0.1% that you are wrong. So that the higher the value you use to make comparisons, okay, the more confident you can be about the conclusion. Basically, that's the rule. But in usual research, okay, when we read, people accept, okay, a standard of 0.05. Okay, so we always look for 0.05. In this case, it's 2 to test. This is 0.05. Now I go down to row 6. So in 0.05, it's like 0.7067 or something. Well, it means that its Pearson value is smaller than this. Okay, it is here or here or here. Then I come to the conclusion that there is no correlation. Okay, if my Pearson value is higher than this, is here, 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 or here. Okay, I come to the conclusion that there is a correlation. Okay, you see that the point of using this critical value table. Okay. That this, there is correlation. If it is smaller than this, there is no correlation. If it is bigger than this, it is higher. And then there is a correlation. I can conclude that there is a correlation. Now in this case, our Pearson value is 0.95 or 0.96. So I can come to the conclusion that there is a correlation. There is a correlation between the the test scores of the supervisor and the test score of the student teacher. Okay. And this is how we write our report. I'm going to give you chance to practice on computers, okay? Because we only work with a very small data set. Usually, in actual practice, you work with thousands of cases, and you cannot do these things manually because it takes weeks, okay, to do manual calculations. Now, the relationship between X and Y was investigated using Pearson product moment correlation coefficient. There was strong, negative or positive correlation. Well, at your level, you do not need to make these conclusions. Okay? And so there was a correlation. Negative correlation means that when X is high, Y is low. Okay? And positive correlation means when X is high, Y is also high. So there was a correlation between two variables, R equal to 0.96 and equal to 8. the critical value. Okay, this is P. Okay. With high test scores of the supervisor associated with high test score or high scoring of the supervisor associated with high scoring of the student teacher. So that's how we write a report. Now let me see if we can Now, please log back into the mobility system. There's several things that I need you to work with. Well, it takes me some time to move these resources, but I want you to go back to topic 4. So click on topic 4. There's a quantitative data analysis there, and you should be able to see a section on Pearson correlation. Okay, I will try to replace that with another link. So for now, I just want you to look at the Pearson correlation formula. And read the explanation about how we find out whether there is a relationship or not. You have to know more about using the critical value table that we have just done. Okay, so again, explain in details how we do the critical value table, how we use the formula. It's now 9:30, and let's take a break for about 20 minutes. Okay? We're gonna come back, and after the break, we will practice SPSS. I need the break time to install SPSS on my laptops. Okay. So, okay, let's take a break. SPSS to help us to work with the statistics. It will be very helpful first when we need to work with large database. On your computer, SPSS is already installed, so simply click on Start button and then type in SPSS. Okay, you should be able to see SPSS 16 showing up. Okay, click on the icon. And this is it. Well, SPSS is a very popular application for processing quantitative data. It's short for Statistical Package for Social Studies. Okay. Right, are you all here? Now, in SPSS you see two views. By default, you will be in the data view. Okay, and you can click on the next tab to see the variable view. Okay, data view, variable view. Now, let's get ourselves familiar with SPSS a little bit by going back to the Pearson correlation that we did before the break. In this research, we have two variables: the teacher, the supervisor score, and the teacher-student score. Okay, so let's create those two variables. So I create supervisor score. Okay, subscore. Now the type of data, as you see here. Now you need to define the format of the data. We can leave it as default. So by default, it will be in numeric number. And if you have already learned to use Excel, you should be familiar with this formatted setting, right? So by default, it will be number. Okay, the width is 8. It means you can enter value of up to 8 digits number, less than 1 million. Okay, and decimal places will be 2. If you want to enter date, like when you collect data about birth date, for example, select this variable. Money can be dollar. If it is simply a text, then put it a string. Now in this case, it's number numeric. I leave it here. Now label. The label is important because usually in research there are not only 2 variables. Some database you may see up to 100 variables, and if you only use the short names, then after several months you come back to the file and you do not make head or tails of the variable that you have created. So the label describe, give you more information. So I will type in here, writing and test score test score of writing exam given by the supervisor. Okay, yeah. So this is to explain the meaning of the variable. Now, for the value label, we can define here so that it show up, but here we do not use the value. When you collect data about, let's say, gender, male, female, what year you are in, freshman, sophomore, junior, senior, then you need to assign a code. 1, 2, 3, 4. We will create label for them. So value 1 label will be freshman, 2 label will be sophomore, and 3 label will be junior. Things like that. When you ask student about the gender, male or female, then 1 for male, 2 for female. In this case, we do not use that kind of label. So just leave it there. None. Missing. Do you allow missing data or not? If you leave none here, then you must enter the data. You cannot leave it missing. The column means the width of the column in the data view. Alignment and measurement. Now by default, it gives you only 3 kinds of measurement: nominal, ordinal, and scale. So interval and ratio come under one scale. And now we create another variable. Let's say student score. And this time I say test score of the writing exam given by the student teacher. Ready? So I have created 2 variables that I want to compare in my research in SPSS. Now let's say this, otherwise when the power is out or something goes wrong with the computer, you lose all your work. So I click on save. You can save it anywhere. So I save it here like SPSS practice on 16th of April. So I click on save. Alright. and a dialog box coming up say, just leave it there. You will be familiar with these things very soon. Now, are you on here? So we have created two variables in the database. Now, click on data view. Now, you should see two variables there, sub-score and student score next to the variable. Huh? Now, it's time for us to enter the data. So let me go back to those things. Research. Now, so enter the supervisor score. Let's say 13, 14, em làm lại một chút xíu. Nó có 10 giờ để xong em có nói là không chịu rồi. Bây giờ tôi đang sẽ để xuống đây. So 13, 14, 13, 11, 11, 8, 12, 9. And the researcher or the student score 14, 14, 12, 11, 11, 7, 13, 9. Well, with naked eye, we can see that they are very close, right? They are very much correlated, but we need to prove it, okay, statistically. So you put in the data, right? Now, instead of using Excel and do all, okay, those calculations that wreck your brain, this is what you do. Okay, go to Analyze, Correlate, and click on Bivariate. I want to correlate these two variables. Okay? And then you should see this dialog box. Are you here? Huh? Then select this variable, and I want to use Pearson test. And it should be two-tailed comparisons. Okay? So just leave it remote. So I select those two variables, and then I click on OK. Now, in the dialog box that's coming up, I get this result right away. Pearson correlation 958. Is it much faster? Okay. And there is a sign here which say, okay, this is positive. I mean, this is correlated. So correlation is significant at 0.01 level. I mean, there is one chance, even if you take only 1% of the chance that your conclusion is wrong, it's still okay. So it means this is very strong correlations. Now, so when we read SPSS, we do not look at the table of critical value. We look at significance. If this value is smaller than 0.05, then it's okay. Okay? We do not need to read the critical value table. This one. So N here, the maximum value is 1. Okay? When test score is compared with test score, I mean when it is compared with itself, it should be 1. Otherwise, it will be 9 by 8. Now, do you understand what you're doing? Try a little bit. Now let's play around. Now this time, let's try to make them very different. Okay? Let's say the supervisor score is 19, and this one is 7, and this one is 10, and this one is 18, and this one is 17, and this one is 7, and this one is 16, for example. Okay, it's like that. Now they are, by naked eye, I can see that they are different now. Right? I run the test again, analyze, bivariate, well, correlate, bivariate. Well, you will be, overwhelmed, okay, at first because of the hundreds of statistics available here. Okay, and then click on yes. You see, now, what is Pearson values? It's 0.016. Very small, and there is no correlation at all. See that? Significance is much bigger than 0.05. So when we do research, actually we use SPSS, okay, to crunch the data. But in the final exam, we require you to do calculation to help you understand the basics, learn the basics. Is it okay now? Okay, now let's practice with the real big research. So go to topic 9. And then click on this folder, SPSS Data for Practice. SPSS Data for Practice. You see this folder? I have uploaded the practice data file here for you. I want you to download this survey 3rd edition. Okay, this is an SPSS file. Now this is a real data from a research in which people surveys, hundreds of staff in a company and measures how they deal with stress, and the other factors that may involve in dealing with stress. So download this file, survey 3rd edition, and then click on the file. It will be open with SPSS. So I think right now, this is trying to install SPSS in your computer. Now click on the variable views at first. How many variables here? 134. Okay, so this is a regular research. It's not 2 variables. And you see, that's why when professors do research, they usually hire assistants. And the assistant collect data, enter the data. It takes a lot of time. Job of the professor is simply to click and then compare. Now, so the ID of the student is there. The sex, you see values, male, female, this is label. Marital status, click there to learn how we input data. See here? So this is like this. On the questionnaire, the question will be, what is your marital status? And this tick, 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 tick. And it will be encoded 1 single, 2 steady relationship, 3 living with partner, 4 married, first time, 5 remarried, 6 separated, 7 divorced. Okay, there are lots of different status because later on in the research they want to see what kind of people are likely to have more stress. Divorced people, or single people, or married people, things like that. And then smoke, because they will also want to see whether people who smoke have more stress or not. So, yes and no. Okay? So you understand how we code data and put it in. When you click on the data view, you see only number. Only number. Now, so I go back to this research questions. This is the questions that we need to ask. Is there a relationship between the amount of control people have over their internal states? So there is one variable. People who try to control their feelings, their internal emotions, and their levels of stress. Our assumption here is that the more people try to control their feeling, the more stressful they can become. It may not be true, because when you ban your feelings, you are in trouble in this. It may generate stress. Okay, so there are 2 variables that we need to do the correlation test. The total perceived stress and the perceived control of internal state scale. Pearson. Now do it for me. Okay? I already told you how to do it, so do it. Now, so tell me, is there a relationship or not? Now, do this. The data is there. Okay, it has a relationship. Is it positive or negative? Okay, so what do I do? Click on Analyze, Correlate, Bivariate. And now I will take out the 2 variables for analysis, the Pearson and what else? Total perceived stress, right? Is it right? Yep. And then I click on OK, just that. I get the result instantly. Now what does it say? There is the Pearson correlation E minus 581. And it is with 2 stars here, double star, and second correlation is significant. I mean, there is a correlation between total perceived of internal states and the stress level. So, the more people try to control their feeling, the more likely they have stress. Okay? Now, next I want to study whether there is any relationship between age and stress level. Okay, whether there is a relationship between how old we are and the level of stress that we have. Okay, if there is a relationship, we may say yes, the older we are, the more stressful we become. This may not be true, but well, let's try it. Now, linear relationship. Huh? Yeah, so the smaller the age, okay, the bigger the stress. Okay, and the bigger the age, I mean the older you are, okay, the less stressful, the less worry you have. Perhaps past the age of 40, people have already got their homes, family, all the things that they can enjoy. At your age, you need to worry a lot of things. Okay? We are be rich, we are be handsome. Yeah. Well, it doesn't matter which one you put it first. Okay. Yeah, okay. You can swap, okay, the two variables. It's not important in this statistics. Okay, so we stop here today. Go back home. I want you to watch the video clips. Okay, read more tutorial about using SPSS, learning more about Pearson correlation, and then practice again. You see, it's not difficult, okay, but you need to practice the calculation too. Next week we will work with t-test, and possibly we may move a little bit ahead to and over. So, any questions or comments before we call it a day?